Today's episode, it's related to how to get started using SLI and SLO. Welcome to Is It Observable? The main objective of Is It Observable is to provide tutorials on how to observe a given technology. Today's episode is a bit special. It's part of a new, fresh series of the channel related to SREs, Site Reliability Engineering. In this series, we will try to explain concepts, tooling, and much more. So if you like today's content, don't forget to like and subscribe to the channel because we are going to produce more episodes. So let's see what you are going to learn out of this episode. So first, we will do an introduction. Then we will focus on explaining what is an SLI, Service Level Indicator. Then, of course, the service level objectives. And today's episode is a bit special. I would like to call a friend to give me more insight, and especially how did Google apply those methods internally. We will also look at what are the various toolings that will help us to keep track on SLO and how to get started. And last, we will make an example on how to get started. All right. So, let's start. Similar to sport, HR, and many other areas, IT requires process that will help us to keep track how reliable are our environment and how they are available. We are all used of using alerts based on thresholds. Alerts are great, but sometimes it's very difficult to keep track on the quality of our products that we are giving in the hands of our customer. So a few years back, Google initiates and introduced the notion of site reliability engineering. By the way, there is an amazing book which is here. You can purchase it on Amazon and various resellers, so take advantage and read it. It's an amazing book. So let's start with the SLI. So the acronym stands for Service Level Indicator. But most of us, we are thinking of any type of metric. But in reality, it's not only one metric. SLI needs to be a ratio of two numbers. So basically, it's the number of good events divided by the total number of events. So if you want to know, for example, if my service is fast enough, I have to think about the distribution of the response times of all my requests. So some of them are fast, some of them are slow. So do I really want to know if the very slowest requests are far too slow? Do I really want to, let's say, know if most of the requests are acceptable fast? Yeah, it's up to you. You have to define this. So I think from my perspective, the perfect tool to measure speed is percentile. We can decide that if we want to know just how many requests are very slow, we call this unacceptable latency. We can express this by asking, what is the 99th percentile of my request every X minutes or every seconds or every whatever? We have to define that pace. Then if it's a query that's beyond that cutoff, then we perceive it as unacceptable. Let's say that everything which is beyond 2 seconds is unacceptable. So we count that query as not good. So we can basically count the number of requests that was good under the thresholds and the one that was above 2 seconds. So we can evaluate that over time. So, and then we can figure out what was the percentage of requests that were acceptable over the last 14 days. So that could be a way of measuring a SLI based on response times. The main concept of production SLI is to avoid using all the metrics that we are collecting through our observability platform. So we are collecting so many data, it doesn't make sense to use everything. We need to understand, the objective is we need to understand what users are expecting from our environment and select few indicators to track the level of our service that we are basically delivering to our end users. The indicator, similar to any metric, could be collected from any observability platform. It could be Prometheus, it could be Dynatrace, it could be New Relic, it could be Elasticsearch, it could be basically all those solutions are data source for our SLI. Now let's jump to SLO, SLO. So SLO stands for Service Level Objectives. Simply. SLI is just a desired ratio. SLO measures if we have achieved the right level, giving the value of our indicator. SLO will define the target during a period of time. So it could be per day, per hour, per month, every 15 days, every 30 days. So you have to determine that period. So one important concept. SLO needs to be reasonable and achievable. The evaluation periods needs to be also properly defined. We usually advise 28 days or 14 days, depending on how much fluctuations and changes are made to your systems. So it really depends on how frequent you're deploying your environments and how many changes you observe on your environments. Some of the SLO solutions of the market provides a score based on the results of SLO. Each SLO basically will collect a certain number of points. We will talk about these concepts later on to introduce the notion of using SLO and SLI for your automation and specifically for your quality gates. So now we understand what is an SLI and what is an SLO. I would like to call one of the SRE experts of the industry, and I'm referring to Steve McGhee from Google. So let's have a quick chat, a quick call with Steve, and we will ask him all the questions that we may have to have a better understanding on SLI and SLO. Hey! Hi Steve, how are you?
Hey, good. How are you, Henrik?
I'm very good. I just explained to our friends the concept of SLI and SLO, and it's great that you are able to take the call with us. We want to take advantage of your expertise, so we have a few questions to ask. So first, I'm pretty sure that everyone here would be interested to understand how to get started, and also how did Google implemented SREs within their organization. So let's start with, how did Google implement SREs?
Good question. Yeah, like it didn't just kind of show up fully formed. It took a long time. So I was a SRE for about 10 years, and I would say SLOs showed up sort of somewhere in the middle. And for a long time, teams were really just kind of deciding if things were healthy on sort of arbitrary metrics, very specific to their teams and their services. And when the idea of an SLO first arrived, it was an extension of the concept of an SLA. It was meant to be like an internal, team-to-team agreement kind of thing, because there was so much interaction between teams. You had to be able to kind of have a deal with each other. So someone kind of decided to have this idea of, it's less of a legal agreement and more of just like a goal that we're both sort of striving to achieve. So hence the name was that it was an objective. It's possible that the name also derives from the idea of OKRs. These are objectives and key results that we use for planning. I think just the name is just kind of sounds familiar to Google folks. And really what it came down to was we wanted teams to be able to kind of have a common language to agree upon a few numbers that you can sort of observe from both sides and agree on if it's working or not. One benefit that we've come up with over time, though, is as more teams, and pretty much all teams at this point within Google, have come up to like a benefit that they've gotten out of this, is that you're able to sort of step into a new team and say, like, where are the SLOs? And people will point you at them, and you can just read them. It's sort of a lingua franca between service teams. Similarly, like if you're if you take on a new dependency with your service, before you do so, you can look at their SLOs and kind of get a sense of how you can expect them to act over time. And you don't have to, go talk to them and understand what it is that they mean by, some arbitrary set of metrics. You can just kind of understand the percentage-based numbers that are really easy for humans to grasp. So that's been kind of the big win of SLOs. The way that we use it in terms of like tooling and things like that, which is kind of interesting, is teams will define their SLOs in one sort of common place. They'll sort of define, these are the metrics we care about, and this is the goals we're trying to set. And we have essentially what you could call it like a compliance dashboard. So you could say, these are the goals that we're setting for ourselves, and here's our history. And so you can see if we've been hitting them or not. And it's just sort of like green, yellow, red kind of idea. And it's, for each service, it's, 2 or 3 boxes of, whether it's, been fast or been available or been, whatever it is that their reliability metric is that they're aiming for. And it's all published, right? It's all internally available. So you can just go browse all of these compliance metrics and see how teams are doing over time. And you can get a sense of what teams are able to accomplish and what their services are capable of. One thing that is not always obvious in terms of what these SLOs are used for is, obviously SLO alerts is a big deal. So if you go out of SLO, or if you're approaching going out of SLO, like if your error budget burn rate is faster than can be expected, is faster than like allowable, we do have this idea of setting off an alert saying like you are going to exceed your SLO if you keep burning your errors this way. Apart from that, like that's kind of the biggest one. Like you got to get that one done first. The other one, which is kind of like it's really the same usage but in a different context, is under the idea of just using an SLO as like a background sort of like measurement when you're doing other stuff. And so by other stuff, like one example I mean is like if you're doing a migration event sort of between let's just say like backing data stores of some kind. You know that you want to be able to perform this large migration in like a hitless kind of way, or at least as close to hitless as you can. And the way to do that is not to invent a new metric and figure out, how many, cache hits you're getting and how many requests are going to the new data store versus the old one, but really just look at the SLO still, same number. Make sure that you're hitting your SLOs while you're performing your migration. And I'm not saying don't track other numbers during the migration. Obviously, you need to keep track of how well it's doing and if you're running out of space or something like that. But using the same sort of reliability, high level of reliability target for day-to-day operations as well as during these sort of special case events is really a great model, because it allows all of the operators to kind of consistently understand if the service is doing well or not. And the last thing I want to point out is, as you're doing these events or as you're just operating it like normal, if you find that you're having trouble hitting your SLOs, remember you can always change them. So it's an internally driven goal. And one thing I recommend to everyone is if you have a place where you define your SLOs, like in your alerting system or in your dashboarding system or wherever, make sure you use comments. It sounds silly, but like there should be code somewhere in your system that defines your SLOs, and in that code there should be comments, and it should say, we picked this number of 9s for this reason, and the reason can be we just made it up. We have no idea. We're going with 3 9s. Because that way, 6 months from now, when someone comes around and it's really hard to hold 3 9s on the system, and they say we have to hold these 3 9s, and you say why, and then you look at the comments and they go, oh, well, I guess there isn't really a why, as opposed to a comment that says like, you have to hold 3 nines because this team depends on you to do so, or this customer signed this agreement that said that we need it there. So make sure that you kind of maintain some metadata around your SLOs to make sure that you're actually holding to the things that matter. I think those are my top sort of suggestions around SLOs.
What is the internal process? Do you usually start from the business looking at customer certifications for a given service, and you build SLO from the production data that you have, and then you reach out to the various technical teams to figure out what will be the best indicators that will allow us to measure our SLO?
I think when it depends on like the maturity of your business's understanding of reliability, because often if you ask sort of like a naive business team, what level of reliability would you want? They would say perfection, right? Like we want 100%. And you can even tell them like, no, it needs to be like some 9s, and they'll say, okay, it's 7 9s, all the 9s. And it's really hard to explain the trade-offs right up front. And so I found that the best thing to do is really just to choose a number based on either past performance that you kind of know is acceptable, or just choose a number and say, we're choosing this for a while, and then come up with an agreement with the business saying, we're going to revisit this number in 3 months or 6 months or 1 month or something like that, and make this into a cycle. So as long as you can set a goal, measure it, and then go back and look at it and say, like, was this sufficient, or was this like way off base, or what? And then being able to measure the customer happiness in some other ways. Like a good example is if you have a customer support and you have like a ticket queue. So when people are unhappy with the service and they file customer support tickets, or they phone the support line or something like that, or number of people abandoning your product, or people that are signing up for your product, things like this. So if you have business metrics, which most companies do, often you will have some indicators on whether the customers are happy with the product, whether they're bringing in more referrals, or they're upgrading to premium, or whatever it is that they're doing. If you're able to make a correlation between a decrease in objective of reliability and a decrease in business output, like that number is really important. So we should strive for the higher level of reliability. But if your business is growing and your users are happy, and you can reduce your reliability targets, that's great. It means that you have more flexibility to be more flexible. Frankly, you can do more stuff, and your customers will be a lot happier with getting new functionality, and maybe they don't really mind fewer 9s over time. So it's entirely possible. So one thing to remember is a lot of services right now are even more and more over time are being used from people's devices in their pockets, phones. And often the reliability of these devices and the network connectivity of these devices is far lower than the reliability of the service that they're trying to talk to. So it really doesn't make sense to strive for 11 9s on a service when you have like a 2 9s phone. So don't try harder than you need to, right? So don't drive yourself crazy.
Just for my curiosity, since Google has implemented globally SRE at Google, have you seen any improvements or less outage, a better customer experience?
That's hard to say. Reliability has always been really a big deal at Google. I would say it's been more about the operation teams. The SREs themselves have been more happy with being able to make explicit trade-offs, and they have had to spend less time worrying and engineering against things that might not have a great trade-off. So being able to have a measure that if we make this number go up, that's our goal. It's almost like it's more of a productivity gain for operations teams. Like you're still going to, like, at the end of the day, if your SLOs are wrong, and your customers tell you about it, right? Your customer satisfaction score drops or something like that because you're tracking the wrong number on the SLOs. you're still going to respond to that. You're still going to fix that somehow, right? The business is going to essentially tell you, oh no, we need to fix this thing. Once you've got the numbers in place, you get a much faster cycle time. So you're able to do more deployments and experiment more and see if it's going to have an effect on the customers or not. So essentially, like, you're able to maintain the level of reliability that you already had, and you're able to perform more experiments and be more confident in their measures. So frankly, like I would say in Google's past, like I said, we always took reliability very seriously. So it was kind of already pretty high in terms of the customer's perception. And really what we're doing is freeing up time within the SRE's sort of headspace to be able to do more stuff and have to guess less, basically. So that's I think would be one of the most important things.
Thanks. So let's talk about tooling that will help us to first declare our SLI and SLO, and then of course keep track on them. So there are several tools on the market. So let's start with the commercial ones, such as Noble9, that by the way organized several months ago a conference called the SLO Conf, and I think you were speaking there, no?
That's right. It was really fun. It was a virtual conference, of course, right now, like they all are. I gave a talk about SLO math, so how to kind of compose your different SLOs from any services and how to think about them kind of in the context of a larger system. It was great.
The other solution is an open source framework built by Dynatrace called Captain. Captain has implemented SLI and SLO and use it within their quality gate. Then, of course, we have all the tooling provided by Google. So Google Cloud Platform Service has a tooling called Stackdriver, but I think it's been renamed, no? Correct?
Yeah, I think it's now part of Cloud Operations, Cloud Ops. But yeah, we just refer to it as service monitoring.
Then we have all the observability solutions of the market that has a support of a notion of SLI SLO. So like New Relic, Datadog, Dynatrace, and more. And there are also a couple of open source projects based on Prometheus. Steve, could you share us a few projects that are available on the open source community?
Sure. I love this model. Like, I really like being able to see the rules behind the SLOs and how they're built up, and really to be able to understand them. I started my days in a system called Borgmon, which is kind of the ancestor to Prometheus. So like, I still think of SLOs in terms of Borgmon rules. So when I look at these Prometheus-based rule systems, it totally looks really familiar to me, and I love it. So there's one that came out. Well, there's a couple from Google. One is called the Prometheus SLO burn example, and it's really just an example. And the idea here is to show you what sort of Prometheus rules you need to have in place in order to start generating SLO numbers, and specifically how to think about burn rate of error budget. And so here you can look at slow burn rate versus fast burn rate. This is a good learning exercise more than like a production stack, but it's something that you can start building your rules based on. And I think going through a process like this is really important because it helps you not just sort of like plug into an existing tool and just blindly follow it, but be able to understand what it's really doing under the covers with all of the time series, and be able to debug the system itself if it's giving you some kind of funny answers. Another one that came out of Google is we have this idea of the SLO generator. This one is a lot more like extensible and like does a lot more. So you can actually use this directly. And so this is put out by some colleagues of mine. It has a lot of integrations with existing sources and things like that. So I would recommend that. That's under SLO-generator on GitHub. And the other one that I want to kind of pitch out there that comes in the open source world is there's the idea of OpenSLO is kind of a up and coming attempt at like rationalizing the frameworks, at least the inputs to the framework. So the definition of how you write an SLO. in terms of really like the YAML. So I can really get behind this. I think it's a good idea to have like a common format between all the different teams. Like everyone can, of course, have extensions and things like this, but being able to have a consistent way to just define your SLO and then have it be implemented under the covers by whatever tool you want, I think is a great model.
It's amazing. It reminds me OpenTelemetry, where SLO is building the standard for SLO. That is a great news. Everyone uses different data source, different systems. We currently have various ways of declaring our SLI and SLO. So having a standard format is great because it means that we could easily transition from one solution to another without impacting our SLO and SLI definitions. It's really a great initiative for our market. And I also think having a described language like YAML is great because it's defining our SLI and SLO in a ASCII code format like you mentioned before. You just need to put some comments, applying changes. It's a great way to keep track also of the various updates that you're making on your objectives. So having the ability to store your definition in a source control, that is clearly will help us to keep track on the changes. So that's great.
That's right. It's really important to be able to keep track of how your SLOs evolve over time, and you should be able to roll them back if you have to. So this is exactly why we have code repository change systems. So making sure that you have someone that can review your code, and that someone can change your code in the future after you've retired and gone to move on a beach or something like that. This is really important. So instead of just clicking inside of a tool and having that value just exist there with no context, being able to set that all in code is super important. Also, it frees you to allow you to do interesting things like use the input SLO definition as an input to other systems as well. So you can use this input to drive like your release automation system, your capacity planning system, maybe your load balancing input system. So in order to understand what's going on with all of your automation, often you want to have a sense of what your SLOs are to begin with. So that way, you can have an input to say, when we're doing a canary release or something like that, we want to know, like, are we hitting our SLO or not? Sometimes you want to be able to refer back to your SLO definition, and having it be in your repo is a great place to do that.
So now let's try to give an example on how to get started, because the definition of things is pretty clear for us now, but I think the journey will be a bit more complicated for our community. And by the way, I would like to recommend for those who wants to get started to look at the various Google workshops available out there. So here is the link to the websites. So you can click on it and go through the websites. It's a great way of to practice and make sure that all the concepts are clear. There's a notion of the SLI menu that I completely love it. So to start building your SLO, you will need to go through the following process. So one, you need to list the critical user journey or business transactions. Try to order them by business priorities. What are the ones that will help you drive your business and your customer certifications? So once we have the list of our important actions or transactions, we will need to identify the metrics that will help us to keep track on the customer certification. So we are basically diving in indicators. So we can think of response time, latency, error rates, conversion rates. There's many of them. So Steve, do you have any examples?
Yeah, the most straightforward one is always just, is it up or not? Is it available? When someone asks for something, are you able to give an answer? And is that answer, not an error? Is it like a well-formed response? So that almost always is applicable. The idea of response time or latency is also important. I generally refer to this just as speed. And so getting a sense of what your customers expect in terms of speed is important. And it's really tricky here. People get really confused when it comes to like percentiles and distributions and things like that. And what are we aiming for? Really what you want to come up with is what speed is acceptable Like what would be a good feeling for a customer, and what would be unacceptable? At what point would a customer be essentially unhappy? And you can find a cutoff point there and say, like, this is the line. Let's not go past this line. And what you do then is you just measure how many things were good and how many things were bad, and in terms of speed. And then that's the highest level way of thinking about SLOs. What's going on under the covers is a little more complicated when it comes to, taking, distributions and measuring them over time and putting things in different buckets and things like that. But really all you're measuring is, are enough things good? That's really your goal. Other types of SLIs that you might be measuring in terms of sort of customer impact that are a little more interesting. We do have the idea of like throughput for a non-synchronous system. So if you have something that's doing a bunch of batch processing, for example, and you need to get all of the computation done before midnight or something like that, or before the billing goes out, maybe. So making sure that your throughput numbers are good enough is a lot more important than how fast each byte or each record makes it through the system. Really what you want to know is, did enough of the records make it through the system in enough time or before some deadline? So you might want to measure things like, transactions per second, or like, what percent of the transactions were satisfied by, halfway through the day, something like that. That will help you to kind of decouple the user happiness, and sometimes this can be an internal user, decouple the user happiness from the implementation and the infrastructure underneath. And you're able to sort of tinker with a lot more in order to achieve the outcome, which is, in this case, getting all the records processed before midnight. That's really what's the most important thing.
Then we have to define our target for each SLI that we have defined. So then we have the error budget, and then we can create alerts based on our SLO. Since the beginning of Is It Observable, we have built tutorials using Google Hipster Shop. In the case of the Hipster Shop, the crucial user journey or user action is add to cart. We want to keep track on two things on this transaction. First, the availability of our solutions, and next, the speed. So how can we build an SLI on this?
There's two approaches. One, you could squish them together and have one SLI, which is, how many good, fast enough requests were there. Or you could split it in half, and you can say just how many good responses did we get, how many satisfactory, and we successfully added something to the cart. How many times did we do that? And then separately, you could measure, are we adding things to the cart fast enough? I recommend doing it the second way if it's feasible for you. Separating those two concerns is it can become helpful down the line. But essentially what you're doing in the availability one is you're measuring successful responses, which in the sort of HTTP world tends to be 200 response code. That's the easiest way to essentially approximate this. If you measure those and then you measure them against all valid requests, you can come up with your SLO. So now the question is, what is a valid request? So you can say, well, if it's a malformed request, someone just types in gibberish into the URL, does that count? Like, are we really counting ourselves as that as an error? Oftentimes we'll say, no, we'll skip those. So we can remove like 400 level errors. And then the other question is, like, do 300 errors count as well? Like, they are redirects. Often we'll use these as part of like the intermediate system to get the system to work properly, and those tend to be ignored as well. But it's up to you. Depends on how you've implemented things. You definitely want to keep track of the 500s. 500s are the bad things. So you don't want to just ignore the 500s. You want to make sure that those make it into the total bucket, the denominator, and make sure that the 200s stay in the upper bucket in the numerator. One thing to look out for is, depending on the frameworks that you're using or the code that you're written, if you're making a request to a backend service and which is making a call to another one, sometimes you'll find the sort of the bad case where you'll get a 200 okay, but inside the body of the message it will say error, right? Like, it wasn't actually okay. So this is a really strangely common problem. So make sure you actually are using the canonical error codes appropriately before you start depending on them for like your critical alerting systems. So like 200s have to actually be okay before you can trust them. So that's an important caveat.
Regarding the speed, once you have filtered on what is a positive or good request, are you already counting the number of good requests that were under a certain response time, let's say 2 seconds, and then you divide it by the total number of requests? Or you recommend to define this notion of speed in your SLO directly?
I've seen it done it sounds a little confusing, but it's pretty helpful. And wherein we have 2 cutoffs. So we have one cutoff where it's a pretty long cutoff where we say like 10 seconds, something that is absolutely, if no one would wait this long, right? So for a correct, an okay response. In these cases, like if something takes longer than 10 seconds, we just call it an error. It might as well be a 500, even though it did respond result code correctly. And then we define another cutoff time, and that is what we expect to be a reasonable wait time. This is the actual speed we're aiming for. And so we can say something like, 1 second is our desired cutoff time. And so we're going to say, for the 2 numbers, the 10-second number would actually go into the availability filter. So we'd say anything that is beyond 10 seconds is marked as unavailable, even though it technically returned a result. And then separately in the latency or the speed SLO, we would say anything that is greater than 1 second, mark it as slow. And then anything that is less than 1 second, mark it as fast. And then we're going to measure slow versus total, right? Which is slow and fast together. So measuring these 2 separately is important because, one is like an error and the other one is like a speed cutoff thing. So we can still be available for most of our things, but we slowed down a bit, and that's going to have a different effect on how we're operating the system. Maybe we just want to add a little bit more capacity versus, something is really, really wrong.
So SLI needs to be measured on a given time frame, a given time window. What would be the time window that you recommend?
That's a great question. So for like the uninitiated, it's important to have this time window because you have to be able to measure these distributions or these metrics over time. And if you're just trying to measure, immediate values, you're going to have some problem with spiky numbers. Like this is essentially like the idea of smoothing out some numbers to run at like business speed instead of like computer speed. It's often the case where you will have like a very spiky moment, which looks really bad if you look at just one really small sample. But then if you look at the whole hour or set of hours, it's actually completely fine and it's irrelevant. So generally speaking, having a concept of why different durations have different effects on your system is an important kind of like fundamental thing to understand. But to answer your question, the recommendation that we have for measuring SLOs is actually pretty long. It feels long when in monitoring terms, as we give it like 15 days, 14 or 15 days, so 2 weeks. And the reason why is because we expect that we're probably not. Our business probably isn't changing that much in that much time. It's probably not undergoing like radical business objective changes in 14-day windows. Also, when we're making changes to the system that are significant, the engineering time tends to take on the order of a couple weeks. Like this is actually kind of akin to a sprint. So if we're measuring things around the same rate as work sprints, whether you use sprints or not, it makes a lot more sense because you're able to see if the changes that you made actually took effect. If you try to measure too quickly, you're not necessarily going to get as much traffic under your belt to really understand the impact of your changes. It is up to you, of course. Like if you have a very fast moving business and you want to measure your SLOs in tighter gaps, like 1 week or even tighter, you're welcome to do so. But just we recommend. We actually, for some of our larger systems, we use 1 calendar month or approximately 30 days. For some reason, we use 28 days off very often because it's just like a multiple of weeks, I think. And then the last thing that we do is we make sure that once you are measuring these over time, make sure you revisit them and say like, is this not only is the SLO itself the right number, but are we evaluating it at the right kind of rate. So is this duration appropriate? And part of the appropriateness is like, are we missing critical events? Or maybe we're looking at too big of a window and we're not seeing these short-lived problems that are actually problems to the business. Or maybe we're looking at too fine a window and we're just alerting ourselves way too often, and we're just wasting our own time. So remember that when you define SLOs, like you can, of course, measure the metric and you can measure the objective, but there's another parameter in there, and that's the duration. So whether it's 14 days, 28 days, or 7 days, something like that. That's another parameter that you can optimize.
So now we have our SLI. So we need to define our SLO, which is a ratio or percentage. So we should not define SLO below 90%. We need to be closer to the 99, correct?
Generally, that's kind of what we've come to expect out of internet systems, is that they're pretty much working most of the time. If you have a system that you're expecting to run at 90% availability, for example, that's a pretty low number for most internet services, and I'd be surprised to see that. We do occasionally have like a 95%. We definitely very rarely see anything that it's acceptable to run a system at like 70% or anything like that. Like we do expect computers to be pretty much on all the time, and pretty much doing their job all the time. The exception does come when it's things like computers that are, in doing something on behalf of people who are in the office at a certain time. So like trading systems for stock trading often come into this, where they say like they need to be running at like very high levels during a window of time, and at night they can be off, like it's fine. So this is kind of an important caveat to like consider like when like if you have the type of service that is dependent on like time of day, you may have different SLOs for different times of day, but just focus on the one that's like steady state. So if you have like a trading floor like application or something like that, set the SLO for the time that the trading floor is open, and that's probably going to be up in these high nines level, and then kind of have a different SLO for nighttime, or maybe just don't have an SLO at nighttime at all, just turn it off, or silence it or something like that.
That brings me a question related to our previous topic. If I know that my business or my user happen to interact with my systems only between, let's say, 9 a.m. and 6 p.m., like a sort of internal application, like you meant, the example of the trader system, for example, should we evaluate the SLI only during the business hours, so 9-6, or should we just find a way of removing the night hours in our evaluation?
That's a good question. I guess it depends on a lot of things, unfortunately, like everything in this business. So like, do your users really only care about the service during that time, or is that just what you've convinced yourselves as a business, is that these are the times that actually matter? Often there's cases where there are important customers who are actually using the system outside of regular hours, and that's the convenience of having computers do jobs for humans, is that they're awake all the time. They don't care. If you really have a time where the system just isn't usable or doesn't need to be usable, like if you have a factory floor or something like that, and they're just like, the machines aren't making tea kettles right now, we don't need the thing to be on, then sure, you can just turn off the system. Generally, I would say like whatever is the most convenient for you in terms of being able to turn it back on again easily, or enables you to not lose data, right? Generally speaking, I would say if you can suppress the system at the last point possible, like maybe the point where it alerts a human. Like if you can suppress that part of the system where it does all the calculation, all the tabulation, so you still have all the data in the system, but you don't actually alert a human at the last minute, the last hop. That's where I would put something like this, one of these sort of suppressing concepts. I wouldn't try to like shut down Prometheus for some hours of the day or anything like that. I'm in favor of keeping more data in the system and just not bringing the humans into the loop.
So basically, we need to filter on the time frame where we have real customers.
Yeah. If you need a human to help a customer, then think about it in that way. When do the humans need to talk to each other? Use the filter there.
Once we have defined the SLI, we need to define and the SLO. we need to define the error budget. So Steve, how do you calculate the error budget?
Yeah. So the error budget it's really easy to calculate. That's not that hard. It's just the inverse of the SLO. So if you have a 99% SLO, then you have a 1% error budget. And then you take that 1% and you say, how many requests came in during this time? What is 1% of that? That's the number of errors that we're going to allow ourselves to have. It's pretty straightforward. The real question is, what do we do with it? And are we waiting for the error budget to be depleted, or are we doing something more clever than that? And I would recommend doing something more clever than that. So if you have, just think of a monetary budget, right? So if you have a pool of money that you're using to spend on groceries during the month, you don't want to spend and spend and spend all month long, and then as soon as you're out of money in your bank account, be like, well, I guess we're not buying any more vegetables for the next 2 weeks. You probably want to see it coming. So what you really want to do is, if you're super into this kind of thing, you want to have some sort of spreadsheet or something where you're seeing how much you're spending each week of the month, and make sure that by the time we get to the bottom of the month that we still have, 1 week's worth of money left. So we refer to this as your burn rate. So, if anybody is, familiar with the startup scene and getting venture capital funding and all this kind of stuff around businesses, same idea, right? You got a pool of money up front. How quickly are we burning it down? So we're doing the same thing with error. Think of errors as our money. So as SREs, we get paid in errors, right? We have this pool of errors that we're allowed to use, and so we might as well use them wisely. You don't want to just ignore them all and just have errors all over the place. But at the same time, if you're allowing yourself to have 10 million errors per month, then use them in clever ways and keep track of them. So there's, in the examples we showed, or we talked about earlier in the previous SLO example, or burn rate example, we have 2 models. One is called the fast burn and one is called the slow burn. And so if you're tracking your SLO over the course of 28 days, you really want to be aware of things like what we call slow burn, where we introduce some new feature and it has a little bit of error, and over time it just trickles and trickles and trickles and trickles, and by the end of the 28 days we've exceeded our error budget. And that tends to be actually strangely difficult and hard to find in traditional monitoring, because it's not like a huge edge to some graph somewhere. It's just this tiny little increase, and then it builds up over time. So we have an example there. And then the fast burn, that's the one that people are more familiar with, which is, we pushed a new config or a new binary or something like that, and it's just broken, right? It's dead in the water, or some piece of infrastructure failed, right? That's when we see these big cliffs in graphs where it goes from, all of the, status code 200s turn into status code 500s all of a sudden. And it's like, oh my gosh, everybody freak out. In this case, what we can do is we can look at the error budget and we can say, we haven't served all of the errors for the whole month yet because we just pushed this bad config to 1 out of 10 servers or something like that. But it's definitely bad, right? If we just left it like this, we would be out of error budget in 25 minutes or 2 hours or something like that. And you can do extrapolation on these numbers pretty easily in Prometheus. So you can look at the angle of the graph and say well, it looks like this. And if we kept going for another 2 hours, we would cross that line at the top, and that would be bad. So instead of waiting for that to happen, we can just do that math early and say, well, it looks like we're burning it too fast. So someone please step in and do something. So that someone can be an SRE. They can come in and they can, revert a change or whatever. And you'll see the error consumption goes up, and then it drops back down to acceptable levels again, and you move on. And no one notices, ideally. So that's the ideal condition with error budgets.
Do you create dashboards and alerts on fast burn rate and slow burn rate?
Yeah, both. So generally speaking, the fast burn rates, those translate into alerts. So those are something that will page a human to come in and do something. And generally you want that to be something very clear. This should be an actionable alert, which is, this is bad enough that I need you to drop whatever it is that you were doing and do this instead. And that might even be in the middle of the night, hopefully not. The slow burn is different though. Slow burns, you don't need to drop whatever you were doing. Instead, we call these ticket level alerts, which is, this needs to be looked at before the end of the month or before the end of the period, right? So often we'll have in the slow burn, we'll do it in such a way where it says, you have 7 days to fix this before it becomes a problem, or 14 days or something like that. That way this can be done you can go get a coffee, you can finish working on the tool you've been working on. And then when you have a gap, you can say, okay, I'm going to go check on this thing, and you can figure out what's going on. And these tend to be, frankly, pretty subtle too. So they might take a while to really dig into. And you might uncover something deeper and more nasty than you expected. So giving yourself the difference between paging someone and like setting like a slow, thoughtful, cadence to work through a problem is super important, and those translate directly into fast burn and slow burn alerts. So the response should not be the same for both of them. One should be a page, one should be a ticket.
What do you recommend to all the teams that would like to get started and that would like to implement SLI and SLO on their project? And for those who's working in microservices architect, do you have any recommendation on SLI or SLO related to service components?
SLOs sound really easy, and they're not. So we've talked for an hour today just on really, really basic stuff, and it can get a lot less basic than that. And it depends on the tools you're using and the services that you're talking about and how they interact with each other. It actually becomes more complex over time. So don't take it too simply. Put some thought into this. There's a book on this. So Alex Hidalgo wrote a book on SLOs. I highly recommend it. We have a bunch of resources on the Google SRE pages that we can link in the show notes as well. But generally thinking like the best thing you can do is think about your customers' happiness. Like what keeps your customers happy with your system today, and what would cause them to be unhappy. And if you can kind of enumerate all the ways your customer would no longer be happy with your service, those are your SLOs. So try to nail those, and you'll be good.
All right, thank you so much, Steve. It's amazing to get your insights. I will try to probably invite you to other episodes. So see you soon. See you.
All
Bye.
Right. Happy to be here. See ya.
So that's it for today's episode related to the how to get started on an SLI and an SLO. So if you enjoyed today's content, don't forget to like and subscribe to the channel. So stay tuned. Other episodes in this series will be available soon. See you. Bye.